These are notes for P5 factoring polynomials. It's a blank screen because I just want to do a little preliminary before we get into the notes. So last section we did multiplying polynomials. So for instance, if we had x plus 3 times x minus 2, we did the box method, or we distributed FOIL, so that would give us x squared minus 2x plus 3x minus 6, and that would give us x squared plus x minus 6. That's multiplying. Excuse me, now we're going the opposite way. We are factoring. We're starting from here and going to here. That's very similar. It's exactly the same thing, actually, as if I have originally 4 times 3 and I tell you to multiply and get 12. Well, now we're going 12 and going into 4 times 3. Note we could also factor 12 into 6 times 2 and so on. So that what we're doing is essentially going backwards from the direction that we're going. So our goal is, and I'm going to reference back to this when we get to quadratics, what are the methods we use to factor polynomials given a particular situation? So first, the first method we're going to look at is greatest common factor, then factoring a quadratic when a is equal to 1. I'll explain what a is. Then we'll look at factoring a quadratic when a is greater than 1, the difference of two squares, that's number 4, and then factoring a perfect trinomial. So first off, greatest common factor. Since they're not like terms, we can't combine them. And then what we do is we look at the 3 and the 12 and say, well, what's the factors of 3? Factors of 3 are 1 and 3. The factors of 12 are 1, 2, 3, 4, 6, and 12. And what's the greatest one they have in common? Well, they have a 1 in common, but they also have a 3 in common, and 3 is the biggest of them, so we put that out front. If we have an x cubed, and the factors of x cubed would be x times x times x, and the factor of x squared would be x and x. So we're asking ourselves, how many do they have in common? They have 2. The most they have in common is 2. So we're factoring out an x squared. And note, this is the opposite direction of multiplying in. So we are undistributing or pulling them out. The way I think when we do greatest common factor, the way I think of numbers is I go 3 times what gives us 3, or you could go 3 divided by 3 gives us what? That would be 1. I'm going to put a 1 there as a placeholder for right now. So that's how I think of numbers. You either go 3, this number right here, 3 times what gives us 3, or you could do it as 3 divided by 3 gives us 1. For variables, I think I'm taking 2 x's out of both of these. Well, if I took 2 x's out of this one, how many would we have left? We would have one of them, x to the first. Now, since I have a variable there, I don't need that 1 in there, so I can go ahead and erase that. So we just have the x there. Just going to try moving that over. Maybe not. Okay, so we have the x there. And now we're going to do the same thing with the second term. We have a negative 12, so I say 3 times what gives us negative 12, and that would be negative 4. The other way we could think about it is negative 12 divided by 3 gives us negative 4. And also, remember, we're pulling out an x squared out here. So how many x's would you have left? You would have 0 of them. That would be x to the 0, and anything to the 0 equals 1. So all we have left is 4. So that would be our answer in terms of greatest common factor. Factoring a quadratic. Well, coming back to what we had before, or something similar, let's look at, this is what we had, x plus 3, x minus 2. And let's see the pattern here. If I multiply that out, that'd be x squared minus 2x plus 3x minus 6. That would give us x squared plus x minus 6. So we are trying to now, in this problem, we're trying to go from here up to here. So we want to look for some patterns here. Well, when we have a binomial times a binomial, it gives us a trinomial like this, for the, at least in this situation. We'll talk about other situations as we move forward. But let's look at the patterns here. We have an x squared, an x term, and a constant. Well, the coefficient in front of x here is 1. Well, how did we get that 1? That was adding these two numbers right here. So this number, which are these two numbers, show a pattern here with the quadratic. The pattern is that if we add these two, it gives us this number out in front. And then if we see in terms of the -6, we got that by multiplying these. So if we want to factor this, the way that we figure out this term is we're looking for two numbers that add to be that number and multiply to be that number. So this is, which most of you have likely seen, is the idea of MAF or MAG or MAL or MAS. There's different, that last one, I put F for factoring. So that we're looking for two numbers, they multiply to be 15. So we're going to put a 15 here. We're looking for factors of 15 that also add to be -8. So my factors of 15 are 1, 3, 5, and 15. So let's group those together. 1 and 15 and 3 and 5. So if I add 1 and 15, that gives us 16. That is not, 16 is not -8. So it's not 1 and 15. If I add 3 and 5, that gives us 8. We don't want 8, we want -8. So this poses a question that when we multiply two positive numbers, it gives us a positive, but we could also multiply two negative numbers to get us a positive number. So if I flip the 5 and the 3 to -5 and -3, -5 times -3, -5 times -3 equals +15, and it adds to be -8. And that's what we want. And we see just like we had before, that our structure of our factoring looks like this, where we have x's here, and then our two factor terms, the 5 and the 3, go in here. So whenever your coefficient of a, this is out front here because remember it's ax squared plus bx plus c, this a is 1 here. Once you get this factor term, you can just insert it there. Now let's quickly talk about these numbers right here. If this is a negative number, then one of these has to be positive and one has to be negative. How do you know which one's negative and positive? Well, you want it to add to be this one in here. And if one's positive and one's negative, let's say like -3 and +2, then it's the difference of them. -3 plus 2 is -1. The difference of their absolute values. We'll talk more specifically, but I know most of you have seen this quite a bit. So this is essentially a refresher, but I can also speak individually with you if you're having concerns with factoring. Now down here, there's a little bit more going on here when our a value is greater than 1. So what do we do when our a value is greater than 1? Well, let's come over here and look at, let's see if I have 2x minus 1 times x plus 3. And we distribute this out, we get a 2x squared. We get a 6x, a -1x, could just written it -x, but there's a reason I wrote the -1x, and then a -3. Now we get 2x squared plus 5x minus 3. So imagine if we're here and we want to get up to here. So if we did MAF like we did above, we would go, they multiply to be -3 and add to be 5. Well, that's not even possible. There's no two whole number factors of 3 that add to be 5. So there's something else going on here. So coming back up to what we had before, if we had, I'm going to have to rewrite it. So if we look here, when we had a polynomial from, I changed this up from what we had before. This might have been a minus and then a plus. But in any case, if we look at this, if I distribute this out, we have a -2x and we have a 3x. And that would be, if we simplify this all the way down, that would be x squared plus x minus 6. And if we do MAF on that, multiplies to be -6, adds to be 1. Our factor terms would be 3 and -2. So again, m is right here, -6 and 1. And our terms are 3 and -2, which we have. They are also right here. Our two terms are right here. And that I wanted to cue in for this problem, that perhaps these are our factor terms right here. Let's look at that. Let's say if we try to uncover our MAF for this one, when our a is greater than 1, let's say if we put in this 6 and -1 down here. Well, that 6 and -1 adds to be 5, of course. What does 6 and -1 multiply to be? 6 times -1 is -6. So let's see if that works here. where is there a negative 6 within this quadratic? Well, if we take the 2 times the negative 3, that would equal negative 6 adds to be 5. And then we get our factor terms right here, and then we got to figure out a method to go from here to here, which we'll work on. So that works. When we have a greater than 1, you need to take the first term a and the last term c and multiply them together. Just to note, we actually do that up here, but we don't need to because this is 1. 1 times negative 6 is negative 6. But since this is greater than 1, in order to get this m term, that's the end goal here, we got to take this and multiply it by that. So let's come back over here. So coming back over here, we're going to take the a times the c term. The a term is 2, the c term is negative 6, so we're going to multiply those. So 6 times negative 2 is 12. Adds to be the middle term, which is 1. Our coefficient of x is positive 1. So now we're looking at what two numbers multiply to be negative 12 and add to be 1. Well, since they multiply to be negative, that means one of them has to be positive and one has to be negative. And they add to be 1. So we're looking for numbers, the factors of 12, that have a difference of 1. Because one of those factors is going to be positive and one's going to be negative, and it's going to be the difference of them. So if I look at 1 and 12, the difference of those is 11. That's not 1. We don't want that. If I look at 6 and 2, the difference of those is 4. We don't want that. 4 and 3, the other pair of factors, has a difference of 1, so those are ones I want. Now we need to figure out which one's negative. Well, we want it to add to be positive, so we want the 4 positive and the 3 negative. Note, if it was negative 1, then we want the negative 4 negative, the 4 negative and the 3 positive. Okay, now if we use the method above, we would go to this, x plus 4, x minus 3. Don't write that if you are writing along with this. That doesn't work because if I distribute that out, x times x, we'll see it right away, x times x gives us x squared, not 2x squared. So there's something else we need to uncover here. There's one way we could do it is the area model. The area model, which I'll show you right here, would look like this, where now our first term is 2x squared. Remember, we have the inside now. We have the offspring of the Punnett square. And we're trying to find the parents, the factors. The last term is negative 6. And now we need two middle terms. Remember, this middle term is split up into those two. But since it's x, it needs to be 4x. And it also has to be negative 3x. Because 4 plus negative 3 does not give you x. It gives you 1. You need 1x. So that's, if we use the area model, you take your factor terms right here, and insert them right here with an x. So now, in any direction, we can GCF. So these two have a GCF and they're going to go up to here. These two have a GCF, they go up to here, or this way or this way. I am going to go this way. I like looking at the 2 and the 4 and going, what's my GCF at 2 and 4? It's 2. And then what's my GCF of x and x squared? They have one x in common, so that'd be x. And once we get this one term on the outside from the GCF, now we know that this multiplied by this term, whatever it is, gives us 2x squared. This times this term gives us that. And once we get these two, we can use this times this to get this. So if we have this and we need to get this, we can find that right there. So once we do GCF, then it's just kind of putting the puzzle together and figuring out what we need to multiply. So I'm going to start off with trying to find this one. So I have 2x here. I have to multiply 2x by something to get 2x squared. Well, I already have the 2, so 1 times 2 gives us 2. And I have an x here. I need an x squared, so I need another x over here. So I have an x there. Now I'm going to decide to go x times what gives us negative 3x. Remember, I just got to get these two blanks. I can go in any order I want. So now I am going to do the top blank by going x times what to get negative 3x. That would be negative 3, because negative 3 times x gives us negative 3x. Now we need the last blank right here, which we could do this times what gives us 4x, or negative 3 times what gives us negative 6. I think negative 3 times something, negative 6 is the easiest. So negative 3 times 2 gives us negative 6. And now I have my factors, the top one. And it doesn't matter what order you write it in. Again, that's important for a quiz coming up. Doesn't matter what order you write it in. 2x minus 3 times x plus 2. I think it's preferable to put the 2x before the x as far as the binomials, but it's not necessary. Okay, another method is if you take, this is a quicker way, requires a little more, it's not as solid of a mathematical process, but it works, so we can go with it. What you can do is you can start off with x here, plus you take your factor term, 4, and divide it by your leading coefficient, which in this case is 2. So go x plus 4, divide by 2, x, and then our next one is negative 3, so you can go x minus negative 3, divide by 2. You do that with both of them. You take your factor terms, divide by the leading coefficient. Now, if it's reducible, this fraction right here, you go ahead and reduce it. So plus 4 over 2 gives us 2. And then, right here, if it's not reducible, you simply take the 2 and move it out in front of the x. 2x minus 3. The reason that works is because typically when we're solving a quadratic, we set it equal to 0. And if I solved this right here set equal to 0, it would give us the exact same solution as that set equal to 0. So it's kind of a quick, somewhat of a cheating way of getting the quadratic. It's not as mathematically sound, but it does work. And there's other methods as well, but I'll stop right there given the length of our video so far. Difference of two squares. So difference of two squares, the pattern looks like this in general. If I have a squared minus b squared, it factors into a minus b, a plus b, and that's exactly the same as what we saw with multiplying by the conjugate. So the pattern that we see here is that a squared, a and a, so whatever this number is, you square root it to get your first terms. The square root of this will give you those terms. And note our middle terms would cancel out if we FOILed this out. So what you're looking for is the difference of two squared terms, and we do have two squared terms. So what we can do is write our open parentheses and then take the square root of that, which would be 4x, and put that in both slots there. Then we take the square root of that, which is 7, put it there. One time minus, one time plus, order doesn't matter. And that's all you have to do for factoring difference of two squares. A perfect trinomial. Why is this a perfect trinomial? It's a perfect trinomial, I'll give you the end game, because the two binomials end up being exactly the same. So let's go ahead and do MAF on this, as this is a quadratic with the structure that we talked about earlier. So multiplies to be 25, adds to be 10. Two factors of 25 that add to be 10 would be 5 and 5. So since this coefficient is equal to 1, we can go straight to the binomials. And we have x plus 5 times x plus 5. And then to get in complete factor form, that is x plus 5 times itself. So that's x plus 5 squared. Note, that is your complete factorization of a perfect trinomial.